Hello and welcome to this video presentation of the weekly project Milestone 6 done by Giorgio Sayyah and Anthony Saibi. So the objective of this project was to design a PLC program through a ladder diagram that will act as a quality control system on a specific industrial machine where bottles will be passing on a conveyor and bottles with a weight that doesn't match the required weight will be refuted. So as we can see here, the input one is a normally open button, which will act as our start button of the system. Input 2 is a normally closed button, which will act as a stop button or as an emergency button, as it would be called on such machines. And output 1 is the motor of the conveyor. Now A1 is a relay that is latched to the input 1. This relay will be energized when output 1 is turned on or the motor is turned on. So this will keep the system running after the start button is released, and thus the system will keep running until the stop or emergency button is pressed, therefore stopping the system. So this was the rung one in our ladder diagram. Okay, now as I said, the output 1 is the motor of the conveyor, and input 3 is the weight sensor that will detect a value and register it in the registers over here. I will be referring to it in a few moments, but it will be registered in the value 2. I will be referring to this table in a few seconds. Now, when output 1 is on and input 3 is on, it energizes relay 2 that is latched to input 3, and relay 2 will only be discharged when the timer ends, and I will be explaining the timer in rung 4. Now, the use of relay 2 is to keep the system running even after the product passes the weight sensor. Thus, because even after the product passes, we still need the system to continue in order to refute this product. Now, in rung 3, A2 is the relay that we just spoke about. This value in the comparator over here, the value in source A, the value N2, the one I referred to in the registers in the second column, it will be compared to the value 2 because we need the product to have a weight of 2 kilograms. So this comparator, it will compare if this value is different than 2. So we only need the circuit the current to flow when the value is different than 2, thus opening the quality control gate and letting the defective bottle exit. And this system also will be reset by the timer 1 that I'll be explaining later. Now output 2 that is latched to the relay 2 is the solenoid valve of the gate, the refusal gate of the defective product. So this gate will close once the 20-second timer is over. Now in rung 4 for the timer, the output 2, which is the solenoid valve, it energizes the timer over here. This timer will have a time base of 100. Thus 100 multiplied by 20 will have a 2-second timer, which will reset our program every 2 seconds. Now to simulate our program, I will first input in the register a value of 2, which is actually the required value of the weight. And we will start the value of 2, and we will start the simulation. Okay, input 1 to turn on the conveyor. Okay, so as we can see now, the conveyor motor is on and the conveyor is running. Just to test the emergency button over here, if you press it, the motor switches off. Okay, once it's pushed back off, the conveyor turns back on. And since normally in machines the buttons are release buttons, that's why we use the relay in A1, so that after the button is released, the conveyor is still running. Now, input 3 detects a value, which is the value that I plugged into the register, which is the value 2. Okay. Since the value is 2, the solenoid valve is not opening, thus the bottles are passing. Once the value changes in the register, let's say 3 kilogram or 3 kilogram bottle passes, this now we can see that the refusal motor or the solenoid valve is open, and thus the gate is open, and the bottle was refuted. Now for the timer, we need to plug in the values. Okay, so after plugging in the values, a time base of 100 and a preset of 20, so we have 100 times 20, which is 2000 milliseconds. We see that the timer is running for 20 seconds and then resetting our circuit, our program. So once the input 2 detects a weight that is acceptable, let's say we take it back to 2, it's it goes back to functioning properly, because this is the weight that we needed. Okay, so this is our project. A report will be attached to the video, to the email, and the link will be available in the email. Thank you for your time.